Hello friends, today we will discuss our next topic, that is IPv4 addresses. IPv4, that is Internet Protocol version 4. In the market we have the first generation of IP, that is IP, we call it the IPv4. Then after that we have the next, that is IPv5, Internet Protocol version 5, and then we have the Internet Protocol version 6. So we will start our theory with the Internet Protocol version 4. Well, today we have the unique and universal addressing scheme, that is called the IPv4. So we will start with our theory, that is IPv4 addresses are unique and universal. Unique and universal, that means all the computers which are connected to the internet, they are having a particular IP address, that is IPv4 address, that is unique. That means everybody have their own IP address, and that will never collide with anybody else. So that means they are unique and universal. So we can also say that the two devices on internet can never have same addresses at the same time. Now the very important thing to be noted, that the IPv4 address is a 32-bit address. Now suppose we have particular m number of computers connected to the internet, that means we need m number of IPv4 addresses so that we uniquely identify these particular computers over the internet. So if a device operating at network layer has m number of connections to the internet, then it needs to have m addresses. So that is all about the IPv4 addresses. Now to understand the IPv4 address, we will first start with the header of IPv4. To understand the IPv4 header, we will draw the diagram of header. So the first field in IPv4 header is version, next one is IHL, next is type of service, next is total length. In the next row we have the field that is identification, next we have DF and MF, next is fragment offset. In the third row we have first field that is time to live, next is protocol, and the last field in the third row is header checksum. Now the fourth row have the field that is source address, second last is destination address, and the last one is options. Now that is the complete IPv4 header. Now we'll explain the fields one by one. So first we will explain the version. Version signify that we are having a particular version. For example, we are using the IPv4, then we are using IPv4 as the version, and we will fill the field version as IPv4. Then we have the next field that is IHL. IHL stands for the length of header we are using. In particular packet we are having the combination of header and the data. So that means that the particular header size, the length of particular header is defined by the field that is IHL. The next field is type of service. Example, we are using any particular service like telnet, FTP, remote client, remote procedure. These services are provided by the third field that is type of service. In the next one we have the field that is total length. Total length is the combination of both header and the data. That means that it is the total length of both the fields of header and the data. And the maximum of total length is 65535 bytes. Now come to the second row in the IPv4 header. We have the first field that is identification. Identification field signify that the newly arrived fragment belongs to which datagram. For example, we are sending a particular fragment and that belongs to which particular datagram. It is defined by the identification field. So next we have the two fields, that is DF and MF. First we will start with the DF. DF stands for don't fragment. So what does it mean don't fragment? So example, we are having a particular clip or a particular file that we can't send with the help of packets. That means the file should be sent in a particular piece that should not be divided into fragments. So in that case, we will switch on the field that is DF. So DF field signify don't fragment. That means the data packet arrive in a single piece that will not be divided into particular further fragments. So that is all about the don't fragment. So next we have the MF. MF means more fragment. Now say example, we want to send a particular file in the particular different fragments. That means a single main file is divided into various fragments, and after that is sent to the party. That is called the division of fragments or the more fragment. So in that case, we will set the MF field and we will not set the DF field. So that is all about the MF called the more fragment. Nextly, we have the field called fragment offset. So what is the fragment offset? The fragment offset field. Fragment offset field defines the current fragment belong to which datagram. So example, we are receiving a particular fragment, then that particular fragment belongs to which of the datagram, that is defined by the fragment offset. Now in the third row we have the first field, that is time to live. Time to live is a counter which is used to limit packet lifetime, and the maximum time to live is 255 seconds. Now the next field in the third row we have the protocol. Protocol signifying that which protocol we are using, that means maybe it's TCP or UDP or any other protocol. So the next field we have the header checksum. The header checksum field basically used to check out the particular errors in the header, as we have the combination of two things, that is header and the checksum. Header, that means that will only work on the header, and the checksum detects error generated by bad memory words inside the router. So that is all about the header of IPv4. As the IPv4 is the default protocol we are using, so that's why we never use the IPv4, we call it as the IP or the Internet Protocol. Now we will discuss the notations of IPv4. So next we will discuss the notations of IPv4. Notation, that means how we represent the IPv4 addresses whenever we are going to enter in a particular computer. So now we divide the notation into two parts. The first one is the binary and second one is decimal dotted notation. So firstly we will discuss the binary notation of IPv4 address. So now the IPv4 address is displayed in 32 bits, as it is the 32-bit address. Now each octet is referred to as a byte. So we can also say that the IPv4 address is 32 bits address or it's 4-byte address. So in the 4 bytes we have particular 8 bits, that means 8 multiplied by 4, that is 32. So now we will represent the example of a binary IP address. So now we have this particular IPv4 address which is represented as the binary form. Binary, that means a 0 and 1. So we can count that the first octet have particular 8 bits. So now the first octet have the 8 bits. Again the second octet have the 8 bits. Third again 8 and fourth again 8. That means the combination of all the 8 is equivalent to 32 bits address. But as we know that 8 bits is equal to 1 byte. So now the equation will become 8 is equal to 1, again 8 byte equal to 1, 1 and 1, and the combination of all the ones is equal to 4 bytes. So that is the binary representation of any IPv4 address in which we have the number of zeros and 1. So that is all about the binary. Now come to the dotted decimal notation of IPv4 addresses. The next one we have the dotted decimal notation. The dotted decimal notation is more compact and easy to read. Now whenever we write the IPv4 addresses in the decimal form, it is written in particular decimal form and is separated by decimal point. We call it as dot. So now we have example of the dotted decimal notation IPv4 address, that is 117.149.29.2. So now we'll call as the dot, not the point. So that is all about the binary and decimal dotted notations of IPv4 addresses. Now we will discuss the address space of IPv4. Next we have the address space in IPv4 addresses. Now what is the address space? Address space is basically the total number of addresses used by any protocol, just like IPv4. Now for example, if a particular protocol uses n bits to define an address, the total number of address space is 2 raised to power n. Now the address space is equal to 2 raised to power n, where n is equal to the bits used to define a particular address. Why we are taking the 2 raised to power n? Because every bit, each bit can have two different values, that is 0 and 1. So the n bits will have 2 raised to power n. So now IPv4 address use 32 bit. So now the address space will become 2 raised to power 32, or it's equal to 4294967,296, or we can simply call it as the more than 4 billion. So that means the more than 4 billions of addresses are available in market. So that is all about the address space. Now we will discuss few numericals. That means to find out the error in the IPv4 addresses. Now we will find out the errors in following IPv4 addresses. So we will firstly take an IP address, for example 111.56.045.78. So that is my given IP address, and we have to find the error. So the main error is in the third octet, that is started with the 0. So the none of the IP address will start with 0. So that is the main error, that there must be no leading 0. Now we'll take another example of the IP address. For example, we are having a particular IP address just like 222.64.17.7.15. Now that is the particular IP address is given, so we have to find out the error. The error is there cannot be more than 4 numbers in IPv4. So there are 5 members. So 1 is extra. So the error is there can be no more than 4 members in IPv4. Now let's take the third example of IPv4 address. Say it is 67.302.21. So now we have to find out the error in this particular IP4 address. So the main error is that each number must be less than or equal to 255, because our range is from 0 to 255 and the 302 is exceeding its limit. So the error is each number must be less than or equal to 255, and here 302 is out of range. Now the next example is 111.0.13.41.55. Now we have to find out the error in particular IP address. So the main error is the combination of or the mixture of binary and dotted decimal notation is not allowed, because the first part is of binary and the rest 3 octets are of dotted decimal. So there is mixture of binary and dotted decimal notation is not allowed. So that is all about the IPv4 addresses. Myself Ankit Verma. Thank you.